Okay, so the mechanism we're doing now is acid-catalyzed ester hydrolysis. First thing you want to do, of course, is I guess go to the book and make sure you're looking at it. But there's the simplest ester, or almost the simplest ester I can think of. You know the name of this? Let's see, the name of this is ethane. O8. Methoxy. Methoxy, ethane, O8. I admit I will probably usually name this methoxy. Can you guess what I'm going to name this? Acetate. Okay. So this is methoxy acetate. It's just pretty simple ester, and I've just messed up my picture for the mechanism. But we're interested in ester hydrolysis, which means the cutting of water, or cutting with water, and it's acid catalyzed. So we say, let's do this again. There's my methoxy acetate, and it's H2O and H+. In a previous video, I think I said, what is it if that's HCl, which is essentially the same as H3O+, right? If it's aqueous, it's going to be H3O+, because that's a strong acid. The chloride has nothing to do with it, absolutely nothing to do with it. Hopefully you're used to that by now. When you see HCl, this is what you're thinking. That's what HCl looks like. Alright, so what's the first thing that we think of? Well, it's ester hydrolysis, and it's acid catalyzed. So as I implied in the previous video, which was nucleophilic addition-elimination, we said, alright, one way we can make this nucleophilic addition-elimination reaction go better is if we make that a better target. And one way to do that is to draw off electrons. It's already partially positive. If it's more partial positive, then it's going to be even better target. If it's more partial positive, it's going to be even better target. So, boom. When you see this, you ought to pause the video and draw out the next structure. That's a luxury we don't have in class. Okay? Let me suppose you did that, and we're going to get that. Boom. Okay? Now, this resonates. Pause the video and draw that. Okay, that's a resonance. You know the real resonance structure is a hybrid between these two, and that means that this carbon's partial positive. That one's even more partial positive, right? Because in this structure, it is trigonoplanar, but it's bonded to two oxygens, two electronegative elements. I'm sorry, in this one it's bonded to two electronegative elements. In this one, it's bonded to two electronegative elements, but one of them has got a plus charge on it. Right? Actually, there's another resonance charge, another resonance structure that you can build from that. You ought to try. Okay? So the structure that we have then in our mechanism is this. Okay? And the next step for ester hydrolysis is a water molecule, which I have here, right? But it's all in the same bucket. Okay? A water molecule comes in, and if you have a water molecule coming in, where's it going to attack? Boom. Okay? It's a resonance structure, right? Okay? And what do you see happening here? I see students do a couple different things here, and a couple different things which end up being equivalent. But one thing to do is to say, we've got a water molecule, another water molecule in solution, right, which comes up and deprotonates this, which is going to give that, right? And then that water molecule that just picked up that extra proton, is going to protonate that guy. Okay. Then these electrons are going to come down and kick that guy off. What's the leaving group here? You see this is just a subset of the reactions we had before. Nucleophilic acyl substitution or nucleophilic addition-elimination. Okay, and then finally a water molecule is going to deprotonate that guy. And I'm going to let you do that last part yourself. Okay, so that's the acid-catalyzed ester hydrolysis. This is in the book, of course, but I really want you to convince yourself that this is really the same thing. Watch. As nucleophilic acyl substitution. I'll put a minus in there to keep things neutral looking. Okay, leaving group. Boom, boom. These two reactions mechanisms I just showed you is the same as that. It's a subset of that. But over here, we're fiddling around with the targetability of that guy right there, and then of course the ability of the leaving group. Right? What's the name of this leaving group? Wow, good question. What is the name of that leaving group? You ought to be calling it. What's the name of this nucleophile? Okay? You ought to be calling these guys by name while you're doing these mechanisms. Alright, hope that's helpful. Acid-catalyzed ester hydrolysis.